My name is Colwart, and I'm doing the 6-minute lead presentation for the refrigeration cycle, which is the third experiment. The heat pumps move heat from high or low temperature environments to higher temperature environments, so that can be inside of your house to outside. And it, instead of just generating heat with resistive heating for your house to heat your house, it takes the heat from the outside, which can be much more efficient, which can save a lot of energy, especially on your bills. For the experiment, our objective is to operate and measure data to evaluate the coefficient of performance of a heat pump, which is the which is the amount of heat that you transfer from the low temperature to the high temperature with relative to the amount of work that you put in. Next slide. The COP is the heat transferred over the work. And this for heat pumps can range from about 2 to 4, depending on the how cold or hot it is on the inside or outside of the environment. Which a resistive heater would be basically a 1 for the efficiency, so you can be 2 to 4 times more efficient than just generating heat with electricity. This is a basic TS diagram for a heat pump, which shows the different stages. This is idealized, so no losses for any of the parts. And it starts at point 1, which is saturated vapor, then goes through a compressor, and then 2 to 3, which is the vapor goes through a condenser, and 3 to 4 still also through the condenser, and now that it's a liquid. 4 to 5, it is going through the expansion valve, where it'll partially turn from the saturated liquid into a liquid and vapor. And then 5 to 1, it goes back through the evaporator. Next slide. This is not the exact equipment we'll be using, it's slightly different, but it's the Edibon TRCBC test rig, and it uses R134A refrigerant. On the bottom is a reservoir of water, and then they get pumped up through the condenser is on that side, I think, and then that side is the evaporator, and then the compressor is the center, and then the top is the expansion valve. And there's various sensors and gauges that measure all the pressures and temperatures at various different points. This is a better diagram of the whole system. So the water reservoir, which will be pumped to the condenser and evaporator, which will be basically the outside environment so that the system will take and add heat to. The compressor is at the top. That will compress the refrigerant, and then it'll go through the condenser. That will come down back through the expansion valve, expand, and go back to the evaporator and complete the cycle. Next slide. For the data, for the first test, we will be measuring the power of the compressor, temperature inlet of the condenser and outlet of the condenser, and the water flow, the water flow rate. And this will be used to get the COP for the system. And this we'll measure those values from the different sensors and then calculate the COP. This example calculation that goes through that calculation with example the energy into the compressor, and then the temperature before and after, and then the flow rate that's given. It just runs through the mass flow rate, and then the temperature difference, and then the work, and then that goes over the COP and gives COP of 2.6. And then we'll finish that out with the next 3 tests, which will run at 3 liters per minute, 4.5, and 6 liters per minute. We'll collect all the data from these specific sensors and mark those down, and those will be used by the reporter to make some, or to configure all the data. Next slide. And that is all.